Find the inverse of a logarithmic or exponential function. So to find our inverse, we have these three steps. First of all, we're going to exchange the inputs and outputs, our x and y variables. That just means switch them. Second, we're going to rewrite the log in exponential form or the exponential equation in log form, depending on what we're given. And then last, we're going to solve for y and label the function as f inverse of x to indicate that it's the inverse. Example A, the first thing we're going to do is switch our x and our y. And then we're ready to change this to exponential form. So we're going to do that by doing our log-ride, but we can't do that unless log is on the left. So I'm going to flip my equation and then draw my log-ride. So I have 2 to the x equals y. Our last step is just to replace y with f inverse of x. Example B, same thing. Start by switching our x and our y. Switch the equation so that log is on the left. Again, the reason we do that is because our log-ride wouldn't work out. That little curve wouldn't work if log is on the right side. So then we draw our log-ride and write it in exponential form. Our last step is to use f inverse of x instead of y. Example C, we have a natural log in there, so be careful. Remember, we always use base e for natural log. So start by switching your x and your y and flipping your equation. After that, we're ready for our log-ride. Again, I'm using e because it's base e. So here we go. Step 1, really easy. Switch the x and the y. So in example A, I'm just going to flip my x and my y. Next, step 2 is rewrite this in log form. So this is currently in exponential form. I have an exponent, it's y. So I'm going to write it in log form. I'm going to use my log-ride, but I can't log-ride when the exponent's on the right. So I'm going to just flip my whole equation really quick. And now I can draw my log-ride. So log form is going to be log base 4 of x equals y. The very last step on here is to, instead of using y, label the function as f inverse of x. That just tells me that it's the inverse function. Example B, we're going to start by exchanging our inputs and outputs. Notice I'm just switching the x and the y. I didn't bring the 2 with the x or anything, so be careful there. The next thing I'm going to do is rewrite this in log form. It's in exponential form right now, and I want to write it in log form. Before I can do that, I need to move the 5 over so that my 2 to the y is alone. So I'm going to subtract it over. And then, like in the other example, I need my exponent to be on the left side, so I'm going to flip the whole problem. Once I've done that, I can draw my log-ride. So I'm going to go down through the 2, up through the x minus 5, and point at the y. So in log form, we have log base 2 of x minus 5, make sure you have that whole thing in there, equals y. And then the last step, instead of y, I'm going to write inverse of f. Example C, start by switching your x and your y. And then we don't need to add or subtract anything over like we did in example B, because I don't have anything added or subtracted on to the 5y minus 1. So we're going to flip sides so that my exponent is on the left. And then we're going to do our log-ride. Log-ride is going to go down through the 5, up through the x, and point at our exponent, which is y minus 1. So our log form is log base 5 of x equals our exponent, which is y minus 1. Remember, I'm solving for y, so my last step is going to be to add the 1 over. and then I'm going to replace y with f inverse of x. And for the sake of space here, since I'm running into my little icon, I'm just going to erase that and put f inverse of x. And there's your final answer. Next is the independent practice part of the video, so pause your video, try all of these problems on your own, and then restart your video to see my answers. If you have any questions over these, please make sure to ask a teacher for help.